thanks a lot for hosting me tonight. I'm very happy. I have about 200 slides. No, slightly less, but quite a few. So let's try to keep it interactive. So if you have questions, please interrupt me anytime. First of all, I'm really sorry you'll have to handle my accent. I know it's painful, but you know, that's the way it is. I'm sorry. I was born in Switzerland, and that's where I live. So in case you had any doubt, this country indeed exists. I was born actually at JBoss, pretty much. First as a developer when I still knew what it meant to code. Then as a GM for Europe, then CTO. Then I joined a company called Red Hat. Well, Red Hat acquired us. So Red Hat is not the ladies in red. Actually, if you have a Google alert for Red Hat, you'll have plenty of alerts about a group of ladies wearing red hats. So it's a bit confusing at first. And in 2010, we started CloudBees, and we're about 30 bees now in 6 countries. And in the US, we're in 6 states. So we try to be as spread as possible. I guess maybe it's related to the way bees behave, but so we're a relatively distributed team. So tonight I want to go and tell you a story backwards, then talk a bit about cloud computing. What does it mean to developers? Because we hear a lot about cloud, but cloud means different things to different people. And then I'll speak also about why it's useful to have the cloud and why it's useful for you as a developer. And I'll do some weather forecast by the end. First of all, who is using the cloud in some way, shape, or form today, for example, on Amazon? Okay. Who knows about CloudBees? Okay, that's all of the CloudBees employees. That's great. So that's good. Who knows about Jenkins? Okay, great. Okay, so you know that Kosuke is at the back. So let's start with the story backwards. So we're pretty good typically at predicting what's predictable. That's what I figure out in the last few years. So, if we see a blue line like that and I ask you, what do you think we're going to do next quarter? I suspect you're going to tell me B, except if you're pessimistic or optimistic. But, typically when we see things like that, we're pretty good at predicting. When we have something that we call a paradigm shift, it's very difficult to predict what could be ahead. Because it's hard to project yourself in the future and guess what kind of new things you could do with that change. But conversely, once you're on the other side of that paradigm shift, it seems very obvious where you sit, and you wonder how you were doing things back in the days before it existed. So, like today, you're all using mobile phones. It seems pretty natural and so on. And probably some kids already ask you, why in the past did you have those strange phones with cords? Why did you need that, right? Well, yeah, it seems obvious today, but it wasn't that obvious back in the days. So let's see how we can make some comparisons between what we've lived in the past, what we went through in the past, and what IT is like today. So let's speak about electricity. So at the end of the 19th century, we've seen the first electrical generators. So they were big machines, sophisticated. It was really high-end IT back then. But they were very fragile, very costly. So that's not the kind of thing you would have in your flat, typically. So cities started to understand that this would really be a competitive advantage in terms of productivity if they could get electricity for manufacturing and so on. So they understood that that's typically the kind of investment they would need to do at a bigger level than just a single company or single individual. It would make sense to have a community own those equipments and then have everybody consume this electricity. So in 1878, there was an exposition in Paris, and it was, I think, one of the great expositions that took place because you have, for example, the head of the Statue of Liberty that's now in New York. So it was being built, so you just had somewhere in the garden just the head of that. So you had lots of technologies that we use on a daily basis today being exposed for the first time, and that included electricity. And in the year after this event took place, we could see a bunch of cities around the world start implementing the first electrical generators. So you can see all of them. So you have to realize that for the 19th century or early 20th century, those were really the Googleplex of the 19th century. This was high-end, you know. It looks like an old building, but I can tell you this was high-end. But it was not as simple as it seems, you know. Today we're used to have a few plugs, but beyond that, it's pretty okay. You know, you can take your laptop, travel around the world, and it's going to work. But back then, it was not as simple. There was no standard. Was it AC, DC? Should it be 50 hertz, 60 hertz, or you know, whatever? What voltage, what type of plug, what type of SLA would you get? It was all over the map. Speaking about a map, here is Paris in 1902. So you can see a simplified map of Paris. And you probably can't read what's written there, but in each color, you have a different electrical system. So the green one is AC, an AC network with one phase. The yellow one has 5 plugs, or whatever that's called, and so on. So depending on where you were, you would have a totally different electrical system. So I can tell you that this was not, back then the keyword was not mobility, right? So you would create equipment, electrical equipment, just to sit in a specific region, and there is no way you would move around to plug it in a different region. So if we fast forward now, where do we land? Well, you're a consumer like me. You have a plug. It's very much defined what you will get in that plug, you know, in terms of voltage, in terms of current, and so on. Then you have a local distributor that plugs into a grid, and you don't care how this energy is being produced. It could be hydraulic, it could be nuclear, it could be solar, whatever. And if one of those go down, well, that's fine. Another one will pick up, and you'll be fine. So we've really reached a level of sophistication in terms of electricity production and consumption that is pretty amazing. So what is the state of IT today? You know, I told you the story about electricity. It's not just to look smart. We can try to make some comparisons with what we do in IT today. So my feeling is that this is about the same as this, right? We are at this stage pretty much in terms of IT. And if you wondered, the thing on the right is actually the first data center, the first Google data center. So when Google started, they had a bunch of machines. And if you were lucky enough to do a Google search back then, that's what you would be running on. So the question is, could IT evolve in a similar fashion as what the electricity went through? So, you know, I'm sure you've all seen pictures like that. You know, I saw that from time to time when I was doing consulting. Sometimes you see quite a few cables, right? Sometimes it's a mess, and yet it moves. So I think today we're still treating IT as something extremely custom, as haute couture, you know, done specifically for one use case. Everybody has its own little stack because they think it's a better stack. It's very costly. There is a high overhead. You get very little agility with that type of setup. And that's where the cloud comes in. And the cloud is all about standardization. How can we consume IT not in a highly specialized fashion just because we think we know better, but in a standardized fashion because it could allow us to be much more mobile, much more agile, and to do things at a much lower cost. And so the cloud revolution has started. We can thank Jeff for that. Many people had the idea of cloud, obviously, for a long, long time. You know, the kind of analogy I'm doing here is not new. But the problem is, how do you do that factually, right? You need to have a critical mass for at some point somebody to step up and say, well, not only do we have the idea, but we have the critical mass hardware-wise to do it, and we have smart people to actually implement it. And so, you know, it's a bit like life. You need water, you need oxygen, you need a bunch of things, but sometimes it happens, sometimes it doesn't happen. Well, it took place this time. And so now we see a lot of the IT being cloudified. We see a lot of the vendors, the software vendors, reshaping their offering into SaaS offering. We see the hardware vendors reshaping their business into IaaS business, so infrastructure as a service. So all of this is being changed and morphed to adapt to this new cloud model. So a few interesting pictures. This is, on this graph, you can see in blue the consumption in terms of bandwidth from Amazon for their shop, for their core business. That's the bandwidth they consume. And it starts in 2001 and goes up to 2008 at the extreme right here. And in red, that's the bandwidth consumption of AWS, so the cloud at Amazon. So what you would consume if you were to rent machines and so on at Amazon. And you see that it's, this graph probably ends sometimes in the mid-2007. Now you can expect AWS to be slightly bigger, and the blue line would most probably be like a flat line, right? So it just shows the interest for AWS today. So maybe you were too far to see some of the stuff on those pictures, but those are typical data centers. This one is slightly bigger. You can see a guy with actually a bike in there. So my belief is that the cloud will do to IT what electricity has done to the industry. So we're going to go through exactly the same steps, the same standardization, the same regulation of cloud providers and so on and so on. So it's I think a very big shift. I'm actually going to publish a series of blogs that goes slightly more into that topic and explain the various phases and the various impacts. That's just my guess. So you can agree with me or disagree, but I strongly believe that's the way it's going to happen. If you disagree, I suggest that we meet in 2020 and we look at what happened over a beer. And I'm not the type of guy that likes to quote generals typically, but I really like that quote, so I think it's a very good one. So to finish this with this analogy, I think that the power plants are the cloud providers. That's really what's providing the compute capacity. The grid is the internet. That's the generic medium by which we can distribute this compute. And then the electrical plug, this mechanism by which you can hook to that standardized grid, is the browser. Obviously, you have plenty of operating system. You have Android, you have iOS, and so on. My belief is that over time, the browser will become more and more the unified access to this grid. But that's for another topic, I guess. So that's great. So the cloud is great, is there, and it's going to grow, and it's going to be the new electricity. But what does it mean to me as a developer? I understand what it means to IT people, for example. It means that all of the things are going to be much more standardized, and maybe we're not going to own hardware in the future. That's fine. But as a software developer, what does it mean to me? So let's go through Cloud 101 for the not-so-dummies to explain what it could mean for the developers. So this is what developers are used to, which is you're used to build stacks in your enterprise, probably. So you define what server you want to use. Maybe you're going to use some virtualization layer, some Java virtual machine, application server, load balancer, your application, and so on. So we're used to build those stacks, to maintain those stacks, and the science is in how to make sure that you can maintain that stack at the lower cost, that it's extremely stable. How do you do when you migrate from one stack to the other? So you'll find plenty of books on that. That's a relatively known, not science, I would say, a known art. But how do we map that art into the cloud? Do we simply take those existing stack and throw them in the cloud and do everything as is? Not quite. So what you will hear typically when you start using the cloud is you will start hearing about IaaS, PaaS, and SaaS. Who has not heard about those things? Don't be shy, by the way, you know. Okay, so, and by the way, that's a big problem with the cloud, which is, depending on the audience, you'll typically have one part of the audience that are part of the clouderati, they know everything about the cloud, and one part of the audience that doesn't know anything about the audience. So doing a presentation on the cloud is great because it's a pretty sure way to upset about half of the audience. Either you're too technical or you're not enough technical. So, let's go through those layers. So let's decrypt what those layers mean for developers. So the first layer is called IaaS, Infrastructure as a Service. And those are really the Lego blocks of IT. So that's really the smallest block you can consume in terms of IT. It would be like a virtual machine or a compute or storage. I want an IP address. I want to set up that networking rule and so on. And if you were a developer, what that would mean to you is you would say things like, well, give me a server, give me an operating system, put those together, I'm going to set up a firewall and so on. So it's really a, Lego block by Lego block. The good thing is that you can do pretty much everything you want, right? Because it's just a machine. So just build your machine and you're done. But it's very complicated. So typically, why you will use this if you want to build a specific system. So it's not so much about application as it is about system. Maybe you have an exchange system, maybe you have a specific database you want to set up or whatever. So what you care about is not so much just about an application, but a specific stack working on a server. So the good news about that is you've now become responsible for your data center, right? You used to have somebody, a team of people doing IT. Now all of that has disappeared. Now you can do everything from the command line. You can say, okay, Mr. Amazon, give me 5 servers. I want that much storage and so on. And it looks all great, right? But guess what? You don't need to carry that anymore, but you're just doing the work that IT used to do, right? So you can use a bunch of tools for that. You will have heard about Chef, Puppet, and many others. Those are just tools that help you automate those various processes to build those configuration in the cloud or on-premise. But really the cloud is where this is very useful. So speaking about Lego, that's the kind of things you could do with IaaS, right? Do whatever you want, even if it doesn't really make sense, you can do it if that's what you want to do. So that's extremely flexible. So the consequences of using an infrastructure as a service directly is that you end up benefiting from the cloud in terms of elasticity or CapEx, meaning you don't have to prepay for those resources. If you want 1 and then you want 5, you'll get that. So that's a great aspect about infrastructure as a service. You don't need to spend 6 months waiting for the PO to reach the good department and IT guys to set up those machines. That's going to take place directly. But once you have those machines, the type of work you have to do is probably actually higher than what you would need to do on premise. The cloud is very, it moves. So sometimes you receive an email from Amazon saying, oh, by the way, this machine has an issue, we'll shut it down for you. Okay. And well, you have to rebuild it, right? But if you receive that email at night and there is an emergency, you're not going to rebuild your stuff at night, right? So you need to automate. You end up having to automate a lot of things. You need to back up all of that. You need to make sure you do garbage collection. We have a system at CloudBees that just do Amazon garbage collection because it's so easy to snapshot, to back up, to do plenty of things. You end up with stuff left and right, and you're like, who owns this machine? Everybody's like, I don't know, not me. Well, you know what? Let's not kill it because maybe it's useful. So when we had too much of that, we said, we're going to invent a robot that's going to check that every machine is associated with a business, a real business. If it's not, let's kill it, right? And if we killed something that made sense, well, we had a bug in the algorithm. But other than that, it's pretty good. So you have to automate a lot of things. And believe me, you should use Amazon. You should try it. If you haven't done so, it's really magic how you can really create machines and set up things and so on. It's great. But you very quickly discover that if you want to use this in production directly, it's going to be a lot of work to automate all of those situations. So that was the lower layer, infrastructure as a service. If you look now at the very top of this layer, you have software as a service. So typically when people ask you, what is SaaS? You'll say, yeah, it's companies like Salesforce and Salesforce, you know. So Salesforce is definitively the best-known company for this, but you have plenty of others company. You could argue that Gmail obviously is one, Zendesk, NetSuite, well, plenty of those. So, so what does it mean? It means that if you are looking for a solution and there is a SaaS that solves that problem, that's great. You know, it means that in very little time, you will be able to have a solution that fits your needs. No work needed, no setup, no configuration, no nothing. Well, obviously, you might want to configure it a bit, but you know, it's not like you had to set up that. Typically, with a SaaS, the time it takes to get started with a base setup that has some good defaults is pretty quick. It's, at least if you compare it to the time it would take when you receive a DVD or a USB key to set that up, configure, install the good operating system, and blah, blah, blah. You know, no comparison. SaaS is going to be extremely quick. The problem is that as a developer, you will typically find that it's pretty rigid, right? If you don't fit in the canvas, there is no real way you can go out. So some SaaS have a way to extend programmatically. That's kind of a corner case. That's not the true definition of SaaS, which is just a software. So typically, if you want to go beyond, you will probably quickly find that you're limited in what you can achieve. So that's the Lego view of SaaS, right? It's, you know, it looks great, it's well polished and so on, but if you want to extend it, that's going to be slightly awkward. And this led me to PaaS, the middle layer. So PaaS is platform as a service. And so PaaS is really speaking to developers. It's not so much about give me a server, give me some storage. It speaks with a level of abstraction that makes sense to developers. Things like, give me an application, or I'd like a code repository. I want to do some tests. I want a database. That means something to developers, right? But give me a server with some storage, you know, that's because we've been forced to think about IT as we do development. But frankly, it's just a necessary bad. Because if we could avoid thinking about those concepts, we would be fine. You know, it's like we like as developers to think about servers and clustering and load balancers. You know, I was crazy about it because, you know, when I was JBoss, I created the first implementation of clustering. I loved it, you know, as a geek. It was great to do and so on. But let's say we could have a single machine on Earth that could work and that could run all of the possible workload of all applications on Earth. Would I be fine with this? Yeah. I wouldn't need a load balancer. I would not need clustering. I would not need, you know, it would work, but it doesn't quite exist. So we're forced to think about those concepts, those annoyances. But clearly, we shouldn't be dealing with this as developers. So let's go back to our Lego analogy. That would be a platform as a service. So typically, you would run on top of an infrastructure as a service. It's not strictly required. Companies like Google, for example, with Google App Engine, which is a PaaS, run on top of their own infrastructure, which you cannot directly access and, you know, and build systems on top. It's really not visible. And then you have the PaaS with the services that the PaaS providers will provide, and that in green is really the abstraction that makes you not see the infrastructure. You don't see servers and so on, but will speak to you with verbs, with concepts that make sense to you. And then in red, you're going to have your application, your Java application or Grails or whatever you want to do. And the PaaS is going to do the load balancing. It's going to be the failover, session replication. It's going to auto-scale if it detects that you need more resources. At some point in time, you can configure it to say, OK, automatically scale to take that load and then scale down once the load is not there anymore and so on. So all of that hard work that is very hard to implement if you want to do it right is going to be handled by the PaaS automatically and prepackaged in a way that you're not going to see those concepts. So when you use a PaaS, applications, data, that's really what's going to be at the center of your world. It's not going to be, again, backup, storage, and whatever. Don't think about IT. And this is a service. That's a very important point. I spoke about PaaS, IaaS, SaaS, and the last S is for service. Platform as a service, infrastructure as a service. What does it mean is you are not going to be the one that's going to install that software, maintain it, patch it, make sure it's stable and doesn't go down. You're outsourcing all of that. And the only thing you see is an API, and you consume it as a service. And so that radically changes the type of interaction you have with IT or with your middleware, because you're not maintaining that software anymore, right? And that can be a bit confusing because many vendors are trying to pitch, for example, the private cloud or the private solutions and even private PaaS. And what that is actually platform as a software, right? And your team, your IT team is going to be the one that makes it a service, but your team is going to be responsible for running that, for operating that, and making sure it's up and running. So you don't really benefit from the same kind of economy of scale. So first decision is, as a developer, do you want to use IaaS? And you can do whatever you want with it. It's very flexible, but it's complicated. SaaS, very fast. You'll get what you want, extremely good, but constrained if you want to go beyond. Or a PaaS is very flexible. So the PaaS is really the new platform for the developers. That's a cloud platform for developers. So again, this word of caution, could I get a private PaaS? So don't get me wrong, it might make sense in some situation, but most of the time, it's not going to make sense, right? It's like, can I get a private jet? Sure you can, right? It better be rich, it better be big, whatever, but it doesn't make sense for a lot of people, right? Because the idea behind a PaaS and cloud is that a vendor is going to have a completely standardized infrastructure with a huge scale. And you will be able to benefit from top-class setup, top-class engineering, much like a big customer, but you can be a one-man, one-dog company, right? But you will still benefit from this top-class behavior. And as soon as you start implementing this in-house, you're going to be the one in charge, right? So you as a developer might perceive this as a service, but behind the wheel, you'll get your IT guys making sure that the PaaS is running and so on. So if you have 5,000 servers or 20,000 servers, yeah, maybe you're a cloud. But if you have 20 servers or 50 servers or 100 servers, I don't think it makes sense. And also remember that the fact that you have a distinct vendor to handle that is very healthy. Because if you try to call Jeff at Amazon and tell him, look, Jeff, I'm onto a project here, it's pretty cool, but for one machine I would need some kind of custom stuff because, I'm kind of different as a customer. It will not pick up the phone, I suspect, right? And that's good, because if you want the cloud to be efficient and scale, you want this to be a standard. You don't want any exception, right? And as soon as you start having this as part of the same team, you know how it works, right? You'll get two guys near the water cooler and say, hey, Bob, can you just do that for me? Just a favor, For one server, I need this stuff. And then you start having IT guys that do exceptions left and right, and that just kills genericity, that just kills your economy of scale. So it's a bit like, to go back to my good electricity example, it's like if you were going to your electricity provider saying, could I get a 160 volts plug just for my toaster, because I think I'd get a better use of it. That's when things starts breaking. So in summary, the cloud is great. That's really going to be a revolution for the IT industry. It's going to reshape the landscape. All vendors are going to be heavily impacted by that. All software vendors, all hardware vendors. Think about it, right? You were selling hardware to companies. Now companies, if they stop buying hardware, who is going to buy it? Oh, cloud providers? maybe I should become a cloud provider, you know? So HP is going to make some announcement tomorrow. Guess what? It's probably related to some of that. So, so this is going to be a massive impact on this industry. Okay, so that's great. We're going to be much more efficient. You're not going to have to worry much about IT. But why do you need it? Yeah, maybe we're good now, right? Well, if you look at what's going on now, we have a flurry of different movement taking place, of new needs. Mobile is huge, social, big data, consumerization of IT, all of that is generating new needs, you know. How many people, you know, when they, how many people in development teams suddenly they come on Monday morning and the question is like, okay, so the boss said that we needed to have a mobile app for everything we do, right? Because we've seen the ratio of users accessing our website. It used to be 1%, now it's 30% of the users accessing our website through a mobile. So we need to get ready, right? So we see all kind of new apps pop up left and right. So some numbers, for example. So that's the number of desktop and laptops versus, so that's a column on the left, versus smartphones and tablets on the right. And as you can see, in 2011, it's estimated that, well, that's slightly old, so it happened, but essentially, you have more mobile devices than you have good old desktop. Just look at Apple's revenue, right? How much is a good old Macintosh versus iPad, iPhones, and the like, right? It's almost sad to have a Macintosh these days. You look at how much they sell those, and you're like, damn, so it was me buying it. This is the smartphone shipments compared to the dumb phones, right? So how many, so if you go above this red line, it means that you are above 50% of smartphones compared to the dumb phones. So in Europe, it happened sometimes in 2010, early 2010. In America, it happened in 2011. Japan is not even on that slide because it happened in 2008. That's the percentage of traffic coming from mobile devices, for example. For Pandora in green, for Twitter in brown, and Facebook in blue. So in 2011, you had Facebook at 33%, Twitter 55%, Pandora 60%, right? Coming from pretty much nothing in 2008. So that's creating, you know, a whole new range of needs, of applications that need to be adapted to that new form factor. And if we look at also the audience, the load that needs to be captured, right? If we go from the mainframe, mini computers, PC, desktop internet, mobile internet, the number of units that will potentially access your services and generate heat in data centers to compute your request is increasing, right? We go from a few million units with mini computers, hundreds of millions of units for PCs, 1 billion units and plus for desktops, and 10 billion units, you know, 10 as a order of magnitude, right, for the mobile internet. And those are all units that they might be small, but they generate as much traffic as the big ones, right? So you need to have things, on the other hand, to handle that load. So how can we handle that massive increase in new applications, in traffic, right? Well, let's say we're going to have 10 times more new applications to implement in the next few years. How do we do that? So one option is to hire 10 times more developers, right? You might want to suggest that to your CIO. We'll see if that flies. Another option is to pay smaller salaries, like 10 times seems fair. We'll see if that flies with the union. And you can try to be 10 times more productive, right? So you might need to learn to type slightly faster, and we'll see. But those seems like great idea, but that might not be enough. So today, I'd like to offer two solutions. Might not be enough, but I think they're a big part of what we need to do. We need to value failure, and we need to increase productivity. So when I say we need to value failure, it always seems strange, right? Because we've been used to know that failing is not quite good, right? If we could avoid failings, that's fine. So we know that about 25% of the projects fail. Don't worry, it doesn't mean that 75% of the project do not fail, right? You still have a good chunk that we say, well, they don't quite fail because we want to be nice, but they're just a failure as well. So failure is bad, that's we all agree. So what we see is that we try to force success, you know? It's not quite that, so let's increase the budget. We put more people to it, and then we extend the deadline, and we reduce the scope so that it's easier, and we reduce expectations. You know, boss, it's a tough problem to solve. And what we've done is pretty good, actually, right? So at the end of the process, we feel like we've succeeded. Did we really solve a problem? I'm not sure, but let's call it a success, and let's have a beer. So I think we actually need to increase the failure rate of our project. Because if we have to deliver 10 times more applications, the question you might ask yourself is, will all of those projects be good ID? Well, you might do some sophisticated research and check if it's good. You know what? I'm sure that for most of the time, you won't be able to do proper research. So let's try it, right? And can you always know that beforehand? No, sometimes you just don't know. You can do as much research as you want. Sometimes it doesn't work, and that's it. So it's very hard. So if something is a bad idea, we'd better know that fast. That way we can stop it, fail, and move on. So that's typically how we do things on the left. You have, well, I don't have 10 ID here. I have 8, but that's good enough. And you push that to the development team, and then the development team works and produce application 1, application 2, application 3, application 4. So we can see that application 4 failed. Application 2 and 3 were, you know, so-so. Application 1 is a great success. Took a long time to get there, not efficient. Another way to do it is to say, okay, that's fine. Let's have our 8 ID. Let's work on them with much smaller teams. And let's not work on a sophisticated project. Let's try to solve the simplest problem we can as fast as possible. And I can tell you, if it's a good idea, I'm sure even the smallest, crappiest software will get some level of success and recognition. But I can tell you, if it's not a good idea, if it's a crappy and small application, it's really not going to get any success. And then very quickly you can say, well, you know what? Fail, 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 fail. We keep those 2. They're good. And so, you know, I might be stating the obvious here, but I really think we need to be much more aggressive in how we reject ID and how we try. If we want to be able to handle the massive load of new applications we will have to implement. So failing fast with few resources is good. It's failing long after with lots of resources that is bad. So let's now speak about the second thing, how to increase productivity. Because, you know, it's great for me to come and say, you know what, let's be much more aggressive, let's develop things fast and so on. Yeah, but if you have a lot of friction between your development team and IT, and each time you want to start a new project, you have to wait 2 months to get your environment set up, you know, you're not going to be much more reactive. So we must drop friction between development and IT. We really need to reduce that. So how do we do that? How do we reduce that friction? Use a pass. Easy, right? You could see me coming. So before we had a pass, how did we interact with IT? We would tell IT, could you please provision a server for me? Could I get X, Y, and Z installed on that server? Could you please patch my server? Could I get a database dump because I need to do some tests? Could I get a new Git repository? So that's the kind of thing you would ask, right? And then behind, the topology would be set up to accommodate your needs after a few months. With a pass, you will not speak to IT anymore. You'll say, create a new account, give me a new Git repository. I'm going to create my Jenkins test suite. I'm going to create my app, build my test, deploy it to production, and I'm done, right? So it's not so much about requesting steps, requesting intermediary steps so that you can start getting your job done. It's do it, right? You want a Git repo? get it. You want to test suite? Do it. You want to deploy an app on a fully clustered environment? Go do it. A snap, that's what it should take. So, so that's, for example, the CloudBees platform. You will find lots of similarities among PaaS vendors, so I'm not going to just start yet doing the CloudBees propaganda. What you will see most of the time is what you can see on the right here. So that's what most platform as a service will offer. So that's a way to deploy your application. You can scale them. You can have failover. You can leverage some of the core services from the platform in terms of monitoring, in terms of management, in terms of databases and so on. And then some of the vendors will offer a number of plugins, extensions that you can enable as part of your platform to get more features, right? Because a PaaS providers will never be the best company to offer you a NoSQL database or a sophisticated solution like AppDynamics. So you need to have partners to do that. So the way it worked back in the days, which means now, you would actually buy software and start integrating that software with your JBoss or WebLogic server and make sure that it all works and so on. That would take you weeks to get it done. Here, with a PaaS, you just go say, okay, enable AppDynamics, done. It's fully integrated, fully managed. AppDynamics provides the service, best of breed. We provide the PaaS, best of breed. You don't have to spend any time trying to hook those two environments together. That's a huge value of PaaS. It's not just running things, but it's integrating things you need much faster than you ever did. And what's pretty specific to CloudBees is at CloudBees we think that software doesn't fall from the sky. So before you can end up with an application, you need to actually code it. And if you think that things will take place in the cloud, well, that includes development as well. So at CloudBees, you will be able to store your code, your Maven artifacts. You will have a Jenkins as a service available. You will be able to do your build, your test, and then, and I'd like you to watch this slide carefully because it took me a long time to do this fancy animation. So, voila. Thank you. So, what you were able to do then is continuous deployment. So you're able to commit some new code online to your repository. A notification will be sent to Jenkins. Jenkins will do the build and test. If you so wish, at the end of the test step, it's going to dynamically deploy your application to production or to a test environment. And nothing will be impacted. So your users will still see the shopping cart with their books and others in there, but the new application will show up, right? That's the type of thing that if you're Goldman Sachs, I'm sure you could set up, but typically IT shops do not provide that level of sophistication. So, does it even work, right? Because it sounds all very cute, but does it work? So let me tell you about a small company called LoseIt. Who knows LoseIt? Nobody heard about LoseIt? Thanks. I know very well about LoseIt. So it's a mobile application where you can track how much you're eating, and how much weight you're going to lose and so on. They have 12 million users. They handle up to 25,000 transactions per minute on the CloudBees platform. They do real-time monitoring of what people do to make sure they can react very quickly. So they do micro releases and so they can check in real time whether a new feature is actually improving behavior or not improving behavior. If it's not improving, roll back, move on. So, very agile behavior. Well, LoseIt is 4 people, 2 in marketing, 2 in development, right? So 0 IT, 0 operation. They wake up in the morning. One half of the brain is about how to market that product, and the second half of the brain is how to develop the best solution ever, right? That's a level of efficiency you wouldn't be able to have 5 years ago, right? Who was able to do that kind of things, get that kind of success with just 4 guys? So what I hear regularly is, well, but I'm not too much of a cloud guy. I think the cloud is interesting, but is it safe? Is it secure? Is it stable? I'm not so sure. Well, I always find that pretty funny because when you hear those guys and why they criticize the cloud, and I'm sure the cloud has many things to improve, don't get me wrong, right? But typically when you hear them, let's talk about security, right? They will typically take a book on security, the 900 pages book on how to do security well, look at the cloud and think, see, page 264, I'm not sure you do that well, right? But what they don't do is to compare their IT to the 900 pages book. And what they should be doing is to compare their IT to the cloud. And I'm pretty sure that security, safety, stability, and so on is much, much, much better in the cloud than in most companies I was able to visit. Plus, the good thing about the cloud is if your cloud provider goes down, you typically hear about it on CNN. So, and so the real question for me is not so much whether it's stable, should we convert people or not. The wave is going to come. And if you don't go to the cloud, you're going to have plenty of LoseIt come in your field, be a competitor in your field. Do you think it's great to have an application like a Weight Watcher these days when you have a bunch of punks, 4 punks with 12 million users and just 4 guys? You know, whatever your field is, once you're going to have that level of efficiency, go after your market, you might change your mind. So just as an idea, you might want to be that LoseIt first. So anyway, my conclusion, but I have multiple conclusions. That's French genes in me. We can't stop talking, so we have multiple conclusions. So the number of applications is just going to explode because we have new needs, mobile is pushing that, and so on. So you need to change the way you do things. You need to be much more aggressive in recognizing failure. You need to have tools that allows you to be much more productive. You have to stop you have to reduce and kill the friction you have with IT. That's not useful. Just get rid of it. And so, you know, a pass is really the best solution I've found to do that. If you found other ways, they might be good, but I know that a pass is a great solution. And also, everybody knows that pass is pretty early. But you know, I could tell you about some of the customers we have. You know, LoseIt is one, but you could argue it's a small startup. We just released an application in France with AXA Bank, a big bank, where they provide an API so you can access to the bank account. You can start implementing applications that access the bank account information that's directly in the back end, you know. And so the type of sophistication and type of applications moving to the cloud is really real. And for AXA Bank, for example, between the time it took them to start the project to go to production, it was 3 months. They've never seen that level of efficiency within the bank. So everybody in the bank is like, how do you do that? Can we do the same, you know? So it's really, it's really impressive the pace at which this is taking place. So just wanted to say a few things about CloudBees. So that's the propaganda part. We are a PaaS. We're a PaaS first and foremost focused on Java. That's where we come from. That's our DNA. We'll see plenty of PaaS. Some of them try to exhibit a bit the notion of servers and IT. Others try to abstract that away. We at CloudBees think that even though the PaaS that shows the servers and try to show the HTTPD configuration and so on might be good initially because you will feel at home, right? It's not too far from what you're doing. It's actually not the right way to do it because you don't need that. So, you know, take a deep breath and move to a real PaaS that will talk to you like a real developer, speaking about application and so on, and not about load balancers. We have Dev at Cloud, we have Run at Cloud. So if you just have a browser or a PC, that's enough. Create an account, it's free, and you can create your Git or Subversion repositories. You can have your Jenkins with your build taking place in the cloud. You can deploy your application, your databases. You can create your next startup just with a laptop. We are about 30 persons. You can see some of the people on that slide in this room. You have Andrew Lee. You have Stephen Harris, who was leading Java server at Oracle for quite a few years. Kosuke at the back, obviously, Harpreet. And we all come, when I said we have Java DNA, you will find on that slide people coming from JBoss, Red Hat, Glassfish, WebLogic, WebSphere, Alair, Macromedia, Bluestone, and so on. So words you don't even hear anymore. Yeah, we're in Woburn, Massachusetts, but as you've seen, we're kind of distributed. And so if I had one slide you need to remember, it would be this, right? This on the left, which you probably can't read, is kind of the steps you need to go through if you want to deploy a new application. You need to set up your environment, set up your load balancers or firewall and so on. And it's a lot of steps. Some of them are recurring steps, making sure that you keep things up to date, patched and so on. And it's not only a lot of work, but most of those steps are actually things you need to do between development and IT. It's high friction steps. And what a pass is about is the view on the right. So CloudBees in 2 minutes, actually we could do that together. But there is this comment here that is pretty good. I'm not tall enough, that's surprising. Here, so you have this comment, because we have an SDK, essentially a command line tool. We have tool integration with Maven, Ant, Eclipse, and whatever, but a lot of developers like to work from the command line. And so in that slide, what you can see is that we're cloning a Git repository. Then we're saying create an application, -- with CD, which means with continuous deployment, minus t JBoss, the type of the container, I want this to be JBoss, and call it kitchen sink. This is going to create a Git repository. This is going to create a Jenkins build, and this is going to create a JBoss container. And all of those are going to be nicely and tightly integrated, which means that once you're going to do a push, a Git push, it's going to send a notification to Jenkins. Jenkins is going to do the build and test if you have any tests set up, and then it's going to push the resulting binary to production in a transparent fashion, just with one line. So let's go through some weather forecast. By 2020, well, it could be 2025, it could be 2018, don't be too sensitive on that. I think things will be either about SaaS or PaaS. Why? Well, let's say you have a new need in your company. The question is going to be, can I find a solution that is pre-built that satisfies my need? If the answer is yes, use it. Don't even think about it, just use it. You're going to get ready in a snap, let's go. And if it doesn't exist, use a PaaS, because you need to do some custom development to get what you need, right? SaaS, PaaS, done. Operating systems won't matter to IT consumers. That's you, that's me, right? Why? Well, if you ask any PaaS provider, they will tell you that they're trying to get the smallest operating systems they can, what we call the just enough operating system. They don't need all sophisticated behavior, right? They just need a tiny core that just do what they need. And you as a user of that PaaS, you will care about Ruby, Java, that's going to be your API. But frankly, to know that it's BSD, Solaris, Linux, or Windows, if I was to tell you, you know what? I have my PaaS in 2 versions. One of them run Linux at $1 an hour, and one of them run Windows at $2 an hour. Which one do you want to take? I don't know. Will I see anything? No, just the same. Okay, give me the cheapest, right? And so operating systems are going to slowly disappear as we know them today. We don't need those fat operating systems anymore, right? And that's going to have a big impact again on the ecosystem as we know it. Think about Microsoft. A lot of the ecosystem that has been built by Microsoft, this huge success, comes also from the strength of Windows and all of those partners around it. And then, you have Office and you have Microsoft SQL Server. So you build upon this. But once you nuke this core and you start from scratch using API, developers API, that radically changes the game. So I think that's going to have a big impact on the industry. Middleware. Well, that one is a bit sensitive. You remember when Benioff said, when he was selling, when he was promoting Salesforce.com, he had this logo that says software, no software, right? Well, people were like, yeah, I'm sure you're doing software to do Salesforce.com. Yeah, sure, but what we do doesn't matter. It's what you do that matters. And when you're using Salesforce, you don't see any software. You're just consuming a service. The same is going to be true about middleware. When you're consuming a PaaS, you're not seeing middleware. You're seeing API, you're seeing containers, you focus on your application, you throw it on the PaaS, it's going to take care of it. But patching an application server, making sure that your message queuing is nicely integrated, that the transactions are properly configured, that the pool is okay, blah, blah, blah. This is middleware. This is legacy. You won't hear about that. And the economy of middleware, as we've known it, is just going to reshape entirely. And last but not least, just as you thought that YAS was hip, I think it won't matter anymore. Don't get me wrong, it's going to matter a lot to us, PaaS providers, right? Because we need to tell you, where do you want to run? You want to run in Europe, in Asia, on the East Coast, on the West Coast, sometimes because of legal reasons, because you want your data to be in a specific country, sometimes because of latency, you know, even though we're smart, we can't accelerate the speed of light, even though we tried in Geneva recently with neutrinos, but we've been unlucky on that one. So you will care about that. You will care about SLA. Is this cloud provider good or not? But frankly, as an end user, you will care about SLA, about location. But that's it. You won't use a YAS anymore. You will ask your PaaS providers, can you run this in Asia? Do you provide that type of SLA? Yes? Okay, let's go. But chances are high that you will possibly not even be directly contracting with some of those YAS providers. So they are extremely important. They are the electricity producer of the future, but you won't directly plug your toaster in a nuclear plant. You will plug it into a PaaS. So join the light side of the force. Just try it. You know, I've spent 500 slides now telling you all about cloud and all about PaaS, and it's very hard to pitch why it's so great. We even we helped write a book called PaaS for the Dummies. You can go on the website and download it. It's a PDF. And even when you read it, you're kind of like, yeah, looks cool. Not sure that works anyway. So the only way you can be convinced or not convinced about PaaS is to try it. Just go online. If you want to use, actually you should use competitive PaaS as well. You know, try 2 or 3 PaaS and get a feel of what you like, what you don't like. And that's really how you're going to discover the power of PaaS. And to me, it's a bit like when you change a laptop, you buy a new laptop. You know, initially you're like, yeah, sounds cool. Yeah, okay. And then you try your old laptop and you're like, damn, what happened to that old laptop? It's super slow. It's going to be the same thing, right? It's going to be a very smooth ride towards the PaaS, and don't try to look back because it's going to be painful. So it's free. You get all features if you want to try, so you should try. Thank you very much.